So my name's Alan Shreve. I'm at Inconceivable on the internets. And today I'm going to talk about living outside of the cloud. And we'll get to exactly what that means in just a little bit. So I just want to give you an idea of exactly where we're going with this presentation. This one is going to be focusing on the practical nitty-gritty kind of stuff. It's not every day that I get to talk to so many gophers, so I want to go into the real details, sink into some of the things that most of the time I don't get to talk about. So just kind of a quick overview of what we'll talk about in the talk, just a motivation, and then about why we're talking about these things, and then I'll talk about how to embed assets in your programs, how to cross-compile, how to deal with terminal UX, how to do crash reporting, and how to do auto-updating. All right. So why am I talking about these things? Why do they matter to me? I work on a developer tool called ngrok. Show of hands, how many people have heard of or used ngrok? Oh, all right, not bad. So there's a problem with ngrok, and the problem is, so this is the vague architecture diagram of ngrok. It's a tool that runs here. It runs on your laptop. It doesn't run here. And running on a laptop, running on computers that I don't control is difficult. And it's a lot of not here. So that's, I think, unique client activity over weeks over the last month. So there are a lot of users that you have to deal with. So when you're talking about, there are a number of problems that occur when you're dealing with web services, or sorry, when you're dealing with console command line tools, things that you deploy to other environments that you don't have to deal with when you're developing web services. And they add a whole, okay, so web services are not really easy. They're all sorts of distributed systems problems and things like that. But they have a whole bunch of other problems that you typically don't have to think about. So as a thought experiment, think of the typical service that you work on, your web service, and think about if you deployed it every day. No, that's too easy. Think about if you deployed it 100 times a day, and on wildly different platforms and operating systems, and that every deployment that you did continues to run forever. And that each deployment was deployed by a different engineer or sysop or whatever, and that some of them are actually corgis. I grew up with a corgi. They're really bad at computers. Okay, so this is operating out in the real world, out in environments that you don't control. I was talking last night with Baron, and he called these hostile environments, which I like a lot. So just how wildly different platforms and architectures are we talking about? This was a support request I got. ngrok is crashing immediately when I tried to run it on Windows 2000 on some really old hardware. And I was like, why? Okay, I don't know. So I was searching around Google and came across other people had run into this, found an issue on Google code. So a little bit of trivia. This particular processor didn't have the SSE2 instructions. So it couldn't actually do the floating point math that Go typically ships with. If you have this problem, you can actually solve it. There's a special environment variable to change how Go does floating point. So it did actually end up working. All right. So I want to talk about how you embed assets into your Go programs. This is a problem that most of you probably don't have. So what do I mean by assets first? This is what I mean by assets. If you have a website, it's all of your static files and things like that, templates and CSS and stuff like that. And you're like, why do I care about this, right? Why does this matter? And it doesn't matter so much on your hosted service, because you can put the assets on the box yourself, and you can guarantee, right, that I'm going to invoke my web service from this directory, and it will always be able to find the assets because they're always going to be put in this path. But remember, in in the outside world, you have to code for corgis, okay? And they will do horrible things, like they will move your program to an entirely different part of the file system, or they'll put it in a different directory, or after it starts running, they'll move it, or delete it, or I don't know, yeah, they'll run it from shells, like things, all sorts of things, right? They're terrible people. All right, so when you're thinking about deployment artifacts, even on your own systems, this is kind of something that you think about where you're like, oh man, well I could have a whole bunch of extra static assets, but it'd be a lot nicer if I just had one artifact, right? And this is what people are talking about when they build fat jars or wars in the JVM ecosystem, and things that like all of the Python and Ruby programmers are like, oh please, how do we get that, right? So trust me, I've been there. It's just a nightmare. And so what you want is only one. You want one thing to deal with, and you'll see that this actually, it's more than just a deployment nicety. It gives you really wonderful things later that I'll talk to you about later. Okay, so how do you actually embed your assets? There are a couple different options. There are a bunch of people who have worked on this problem before. The one that I like best and use myself is called Go bin data. I don't know if Jim is here, but if he is, he wrote Go bin data, and it's awesome. So Go bin data is a command line tool that auto-generates source files with the binary content of the static files that you want to put into your program. Okay, and it does really clever things like you can tell it to like gzip the contents, or it has special hacks to get it so that it ends up in the RO data section of the program, which mattered like more when the GC would like wonder if all of those things were pointers. And the other thing that I was working with him on it was getting like a really useful interface for using these things. So this is how I use it for actually building ngrok. So anytime I build ngrok, I can't go build it. This is like a separate part of the deployment pipeline. So I invoke the Go bin data tool. And basically, you point it at an output file, and you say, I want you to take all of the static assets and put them in this particular file, and give it a package name. You'll see it's in an assets directory, so I'm telling it it's the assets package. Sometimes you might want to tell it if it's main, right, or something like that. I'm going to give it a tag. This is a build tag that will end up in the source file called release. And then I want to tell Go bin data that it's not in debug mode, and you'll see why that matters. And then you want to pass it where all of the assets are. And it even like recognizes the kind of standard Go way of talking about paths, which is like, give me all the things in assets client and all of the subdirectories under that. Okay, and what it generates out for you is something that looks like this, which is it has a release build tag, and you'll see like it has a map of all of the different assets in there. I didn't list them all out, and the bytes for it. It doesn't actually look exactly like this, but that's the general idea. And then there's an interface, there's one interface, which is ask for the asset by name, and it returns to you the bytes and an error. And the useful part about it is, well, actually, like, let's talk about why that is kind of frustrating. Is imagine you're using that, but you're working on your website, and you're like, oh man, I want to tweak some CSS rules, or I want to change the JavaScript. Oh, I have to recompile. That's really frustrating. So you can also invoke it in a separate fashion. This is how I do it, and I give it a debug tag and tell it that Go bin data has a debug flag, which you tell it true, and when you do, it generates this out for you, which is do the exact, well, don't do any of that. Actually, just read those assets from the file system. So this works really, really well for when you want to like rapidly iterate on all of the static assets that you're working on for websites and stuff like that. But when you actually get to release time, you want them all bundled up into a single binary. And then the way you do this, if any of you haven't used Go build tags before, those things that I was showing you, oops, yeah, that. The build debug means only build this file if you get the debug tag in the Go build command. So if you say like tags debug, it will actually build that particular file and include it and ignore the one that has the release tag, and vice versa. The downside for this is that it doesn't work for libraries, which is kind of frustrating because you're at the mercy of the Go build toolchain. Not entirely. Like, you can actually do it. You just have to pre-compile them. There's no one's going to be able to work on your library that like they did go get for, and then still be able to deal with the debug and release sort of thing, right? Without integrating that into their own build chain. Okay. Next, let's talk about how to cross-compile. There's kind of been a little bit of talk about this. The answer is don't do it. Compile natively. The most practical, and I'll tell you why. The most practical solution I've seen for this is to automate around Vagrant. Believe it or not, like spin up a bunch of virtual machines. I think Juan Benet showed me this. I don't know if he's here. And then like spin up a bunch of virtual machines, build on all the target platforms, and then suck out the binaries. You could probably do it with Jenkins. I've seen some work on using some of the other kind of C tool chains to actually start doing this. Like CrossTool NG is what, like, I think, I'm not sure which projects use it. I think Tor and maybe Firefox or something like that, to actually do this on like a single machine without having to deal with all of the complexity that comes around it. So why don't I want to cross-compile? CGO. You can't cross-compile CGO unless you have, like, you're back into the same auto tools, like, world of C build change, like the thing that we all wanted to escape from. Okay, horrible. Am I right? Okay. No, so you said, well, I don't have any CGO, I'm okay. And I thought that too once in my naive days. There's secret CGO. There's CGO in the standard library that you weren't aware of. So I got bug reports like, ngrok never seems to find its default configuration file. And it's because if you use user.current on Darwin or Linux and you're cross-compiling to them, that returns not implemented because it uses the C API to uses the Unix API and C headers to actually pull that out. And another one I had was ngrok can't resolve POW. Any Ruby people using POW? It creates like this fake .dev TLD that it uses resolve.com to reroute your things, so you get like pretty URLs when you're developing on. But if you cross-compile, you don't actually use the system resolver anymore. You use Go's internal resolver, and it doesn't actually check resolve.conf, and so like that just stops working. If you want to cross-compile, these are some good tools for like, it's really, honestly, like cross-compiling is really not hard, but if you want to do it automated across a whole bunch of different platforms and architectures, these are tools that are really useful and helpful to do it. Okay, terminal UX. So there are a lot of different ways to do this. The one that ngrok uses, ngrok puts up like this kind of user interface when you're using it. I use a particular library called termbox.go. It's awesome. If any of you haven't used it, it's really fantastic. It's like curses, but amazing. So it's also cross-platform, which, wow, really fantastic. Okay, it's still a little low level. There have been some efforts to build on top of it. One that I know is called GoCui. I haven't actually gotten to experiment with it, but it looked pretty cool. One thing, if you do use this, like beware of the shutdown semantics. If you don't clean up properly after yourself, like everyone's terminal, like just, and you have and everyone's like, you ruined my terminal. It's like, all right, well, you get a new one. Okay. Also on the terminal UX, here's a problem that like probably none of you have. Maybe some of you who are developing like CLIs for your web services have this. These are actual support requests I get about ngrok. I downloaded it and installed it, and the terminal window popped out and nothing happened. Hey, I'm trying to install ngrok, however the terminal closes and I can't do anything. Could you give me some help? Does anyone actually have an idea of what is going on here? Yeah, they're running Windows. That's right. Yeah, I can't, like, I don't have a fix for that problem, but okay. So what I wanted was a mousetrap, not that mousetrap, that kind of mousetrap. So I wrote this like last night because I've been meaning to do this for a while, and like I finally was like, I should just do it because it would be cool. So this is Mousetrap, and Mousetrap is like this library that basically detects if someone did like double-clicked it, and it's doing something like really, really horrible, which is like it is the parent process explorer.exe, but it actually does work. super fast demo. Uh-oh. I don't know if I'm going to get this to work. Let's see. No, that might have been too ambitious. I do want to do a demo later, though. I could. Yeah, let's try that. Okay. Oh, goodness. Okay, I think this was perhaps too ambitious. Oh, there we go. That's what I'm looking for. Oh man, this is slower than I thought it would be. All right, maybe we'll come back to that. Really? Like, I don't know. Anyways, if you want to use it, it's on GitHub. It's Mousetrap. The API is like really that simple. There's a single function, and it returns to you like true or false. All right, crash reporting. This is harder. I haven't solved this problem, so I'm just going to talk to you about my thoughts on this. Right, crash reporting, this kind of crash reporting. When you run on environments that you control, when your programs crash, you typically, like, not always, but most of the time you know about it. Like, maybe your pager goes off, or someone comes and yells at you and says, the website is down, like that sort of thing, okay? And it's in your logs, right, about what's going on. When ngrok crashes, like, out in the world, I have no idea. So I was like, man, I wonder, like, how could I get around, like, I really want to be able to, like, capture that panic. Like, if something crashes, like, I want to know about it, like, how could I do that? It's like, well, I guess, like, there's no, like, global way to hook into every Go routine. So maybe what I'll do is I'll have, like, a wrapper function that I spawn every Go routine with this Go wrapper function, and it'll always defer this function, and if anything crashes, it'll, like, print an error report, and with some sort of, like, this is what it actually prints out right now. It says, please upload the stack trace and submit an issue. Okay? Here are the number of errors that have been reported this way. So my conclusion is, all right, that's not actually true. The truth is that people don't want, they're lazy. They have not lazy, they have other things to do. They're busy. Like, they don't want to report these things. If the program crashes, like, it's my responsibility to deal with that, right? So what I really want is an automated way to do that. So I could, like, use that same shim and upload it somewhere to, like, Sentry or Airbrake or whatever. But there's this other problem of, like, what if a crash occurs in a Go routine that I can't wrap? Like, something in, like, another library. Like, it was a Go routine that I didn't even start. Like, the library started it, but it failed because I misused the library. It's still my fault. Or maybe it's not my fault. Maybe it's the library's fault. How do I catch that? So I was trying to figure that out. I was discussing with a friend. I'm glad when you guys were doing the panel that you were into the idea of source rewriting, because that's kind of what I want to do. I haven't actually done this yet, but that's kind of what I'm thinking about. I don't know if that horrifies you, but it's kind of scary for me. What I really want is add exit for this. I don't actually, like, want to do all the source rewriting, but I think it might work. So I actually got around to prototyping it. I haven't, like, prototyped the whole thing. If any of you haven't used the AST package, it's really, really nice and really, really easy. This is wrapping all of the Go routine invocations with basically with a wrapper function. You basically you pass in the parsed AST, and you get you pass a function, like a callback that fires every time. And you can check what type of node you want. So I'm interested in the Go statement invocation, or the Go statement. And then I create, instead, a new call expression. and say, like, no, instead, I don't want you to call that function. I want you to call this wrapper function, and I'll pass into you the function that you were going to call and all of its arguments. And then my wrapper function can do all sorts of awful things like catch all of the panics and upload them somewhere. I'll let you know how that goes. OK. There are a couple downsides of doing it that way. It's like another non-standard part of the build pipeline, like on top of the asset stuff. There's this weird recursion problem of what happens what if I crash when I'm crashing? It doesn't deal with all of the cases. It gets like the operating system like kills it because it was eating up all of the memory, or there's a meteor. Like, okay, but I think it will be good enough. All right. Last thing I want to talk about is how to auto update. Well, not like that. Like more like that. That has a much better connotation for all of us. All right. So how does it work? This is actually how you cross-platform auto-update all of your applications, which is download the new binary, move the current binary to a different spot on the file system, and then move the new one to where the old one was. And believe it or not, that works across all major operating systems, and that's actually how I do it for ngrok. I built a library to do this. If any of you had looked at that library before, you probably ran away horrified and crying or something because the interface was really terrible. The good news is I rebuilt it. So I pushed that code up today. If any of you depend on it, I'm sorry. I hope you vendored your dependencies. So, so the new one has a very nice API and separates out the original one, is conflating this process of, oh, I want to do an update versus how do I check for an update, and is there an update available? And then I added a bunch of extra goodies like binary patching and code signing. So actually, let's try again. This demo perhaps will go better. I'm not going to try and use Windows for it. Not that one. This. All right. So here's this directory that I have. I'm running in this particular, on this console. I'm just running a static file server. So it's actually just serving this tree for me. All right, so what I actually want to look at is, let's go into V1, and let's look at this program. And all this program does is, if you don't pass it anything, it prints out version 1. And if you do pass it the update argument, the argument update, it will actually go and update itself from the URL localhost 6767 v2 updater, which is, right, I'm serving all of that tree via the static file server here. So it should, so you see that is the binary in the v2 updater. So let's actually run that. Prove, okay, it's version 1. And then I'm going to tell it to update. And it says I'm updating from that particular URL. And then if I run it again, I should get version 2. That's basically the whole thing, okay? But so I want to demo a couple of the other features for you, which is, let's demo V2's updater. So V2's updater is a little bit different. It's showing off that it also does checksum validation for you. Important part when you're doing updating programs is you want to make sure that what you actually downloaded and replaced with is what you expected. So let's actually do that. So that should update us. Whoops, I'm not in Vim. That should update us to V3. So I'm in V2. And I'll tell it to update. And now I'm in V3. All right. And then lastly, that's a directory behind me. And the last thing I want to show you is that I integrated Keith's package for doing binary diffing. Thank you, Keith. So that you don't need to ship entire binaries over the internet to people to actually do these updates now. So what we're actually going to do is apply the patch, and then afterwards, after the patch is applied, it will additionally do the checksum verification to verify that the patch got applied correctly, and you still get out the correct whole thing that you wanted. So, all right, we're at version 3. Let's update, and now we're at version 4. Cool. So that's the demo. This is the one thing that I didn't demo for you because I didn't have time to put the whole thing together. It also does code signing, which is kind of the really important piece of like, oh, I downloaded this thing, and it's true that it does match the checksum, but like, how do I trust the checksum? Like, the checksum should be signed. This is how like all of the major like operating systems do this stuff for you to guarantee that you're running safe code, is signing it. And so Go Update has this as well. So you can safely update your code. Your original one will contain your public key, and then you can verify that every update that you apply afterwards is still like from you. All right, that's what the API looks like. Cool. So some of you probably were asking this question of like, that's great, but how do I know what URL to update from? Which is the orthogonal question of like, is there an update available, and where is it? So I'm working on a service. It's up, but it's still kind of alpha. You're welcome to try it. It's a service that takes care of this problem for you. The basic idea is it has an API for automating the updates. So what it's going to do for you is like automatically compute all of those binary patches for you, so you don't have to worry about it, and then also give you the primitive of release branches. Right? This is something that most people don't get, which is like, oh, I have a stable branch and a dev branch and a beta branch, and people can pick whatever their risk tolerance is, or maybe I have a particular client who only like wants security updates or things like that. So it has a very flexible mechanism for defining exactly what kind of update each person should get and can opt into. This is basically what the API looks like. There'll be docs up on the website, but I haven't gotten to write the whole thing yet. But the basic idea is you can post up to it the URLs of the binaries that you want to release, checksums, signatures that go along with them, along with each of the assets for that particular version that you want to release, as well as the operating system and architecture, so that I know which one to ship to each person, depending on what platform they're running on. And then other interesting things I was telling you about the channels, so people can opt into like the beta channel, things like that. And then in your code, this is the more kind of advanced Go Update API, is the check package, which is a sub-package of it, is responsible for doing the check, which is a very simple like HTTP post and JSON exchange of like, this is the current version, and this is the application that I'm interested in updating, and this is my checksum. Like, please tell me where the URL is or where the URL of a patch is, things like that. Right, and like I was saying, the caveat is it's not quite ready yet. If any of you are interested in, just sign up and I'll like email you, or just email me about it. Cool, that's about all I had. I have about 2 minutes. Anyone have questions?